What if the Big Bang wasn't the beginning of everything? It's a question that has puzzled scientists and philosophers for decades. The Big Bang Theory is our best explanation for how the universe evolved. But it might not tell us how it all started. The Big Bang Theory describes a universe that is expanding. This expansion has been happening for 13.8 billion years. It's natural to ask, what was there before the expansion? The truth is, we don't know. Our understanding of physics breaks down at the moment of the Big Bang. It's like trying to rewind a film to the very first frame. We can't see what came before. The Big Bang Theory doesn't tell us about the origin of the universe. Instead, it describes what happened afterwards. Imagine a tiny point, incredibly hot and dense. All the matter and energy we know today was once packed into that single unimaginable speck. Suddenly, it starts to expand. Not into space, but creating space as it grows. Space itself stretches, carrying galaxies with it. The universe cools down. As the universe expands and cools, particles form. These particles are the building blocks of everything. Protons, neutrons, electrons, atoms come together. Hydrogen and helium dominate. Eventually, under gravity's pull, stars ignite, lighting up the darkness. Galaxies are born. Clusters form. Over billions of years, cosmic structures take shape. This is the story the Big Bang Theory tells. It's a story of evolution, not of absolute creation. The Big Bang is often depicted as an explosion. But it wasn't an explosion in space. It was the expansion of space itself. Everywhere, all at once. Imagine a balloon with dots on it. As you inflate the balloon, the dots move apart. Not because they're moving, but because the surface itself is stretching. The universe is like the balloon, and the galaxies are like the dots. The space between them grows, and continues to grow, even now. What existed before the Big Bang? This question might not have an answer. Our understanding of time breaks down at the Big Bang. Some physicists believe there was no before the Big Bang. Time itself came into existence with the expansion of the universe. It's a difficult concept to grasp. We are used to thinking of time as linear and infinite. Imagine a universe with no beginning and no end. It's a universe that always was and always will be. It's a mind-bending idea, but it's one that some physicists take seriously. So, Stephen Hawking offered a really compelling idea about the beginning of the universe. He called it the no-boundary proposal. Now, imagine the surface of a sphere. It's finite, but it doesn't have an edge. Hawking suggested that space-time is kind of like that. It's finite, but it has no beginning or end. Which means asking what came before the Big Bang is like asking what's north of the North Pole. It's a question that just doesn't have an answer. The no-boundary proposal is only one idea, of course. But wow, it's a fascinating glimpse into the mind of one of the greatest physicists of our time. The Big Bang Theory, well, it's not the only game in town. While it's the most widely accepted explanation for how our universe began, it's far from the only idea out there. Physicists have come up with other models that really challenge our assumptions about the universe. These theories aim to answer the same big questions. Where did we come from and where are we going? But from very different angles. Now, these models are definitely speculative, but they're still based on real physics. They often emerge from attempts to unify quantum mechanics and general relativity, or to resolve paradoxes in cosmology. One idea is the Cyclic Model. It's a bold reimagining of cosmic time. It suggests that our universe goes through cycles of expansion and contraction like a cosmic heartbeat, pulsing endlessly through time. So each cycle begins with a big bang and ends with a big crunch. Then from the ashes of one universe, another is born. Another model is called the Ekpyrotic Universe. It's a fascinating twist on the origin story. This theory, which is inspired by string theory, proposes that our universe collided with another universe in a higher dimensional space. That collision sparked the Big Bang. Then there's the quantum bounce. This model suggests the universe didn't begin with a singularity. Instead, it rewrites the very beginning. Instead, It collapsed from a previous state and then, well, it bounced back into expansion like a spring compressed to its limit. The universe rebounded into existence. And finally, we have the theory of eternal inflation. It's perhaps the most mind-bending of them all. This one suggests that our universe is just one bubble in a much larger multiverse, where new universes are constantly being born, each with its own laws of physics, its own story, and maybe even its own version of reality. As theories about the universe's origin grow more complex, scientists are increasingly turning to one powerful tool: simulation. In a realm where we can't recreate the Big Bang in a lab, computers become our cosmic laboratories. Using advanced algorithms and massive processing power, researchers simulate the birth and evolution of the universe, testing how different theories might play out over billions of years. These simulations start with fundamental equations, those that govern gravity, quantum mechanics, and thermodynamics. By tweaking initial conditions, scientists can see how a universe might expand, contract, or even cycle endlessly. Want to test the quantum bounce model? Simulate a collapsing universe and watch it rebound. Curious about eternal inflation? Run a multiverse scenario and track how bubble universes might emerge and evolve. But it's not just about watching virtual universes unfold. These simulations produce predictions, patterns of galaxies, cosmic radiation, and gravitational waves that can be compared against real observational data. If the patterns match what we see in the sky, the theory gains credibility. If not, it's back to the drawing board. Simulation doesn't give us final answers, but it helps narrow down the possibilities. It's like peering into a cosmic crystal ball, one coded in math, powered by silicon, and fueled by human curiosity. In the absence of time machines, simulations may be our best shot at rewinding the universe, frame by frame, to glimpse how it all began. These alternative theories are no doubt fascinating. They offer bold new perspectives on how the universe might have come into being and challenge the conventional wisdom we've held for decades. But the big question is, are they true? Can we find real, measurable evidence to support these mind-bending ideas? Scientists are actively searching for evidence to either support or refute these ideas. From massive observatories to complex simulations, they're using every tool at their disposal. One really promising area of research is the study of cosmic microwave background radiation. It's like a snapshot of the universe when it was just 380,000 years old. This radiation is basically a faint afterglow of the Big Bang, and it holds valuable information about the early universe. Tiny fluctuations in this glow can reveal clues about the universe's structure and origin. Scientists are also on the lookout for gravitational waves. These are ripples in space-time caused by violent events like the Big Bang itself. Detecting them could open a whole new window into the earliest moments of existence. The search for the ultimate origin of the universe is, honestly, a journey into the unknown. It's a quest that spans both time and space, reaching back billions of years. It pushes the boundaries of physics and challenges everything we think we know about reality. Each discovery forces us to rethink our place in the cosmos, but it's also a journey full of mystery and excitement. The deeper we look, the more questions we uncover. And who knows, it might just lead us to the most profound discovery of all, the true nature of the cosmos and perhaps our own origins within it.